right, but for unit 2 on the constructed response, you have two choices. You could solve a system by graphing, and you would have to know like the algebra for how to graph it by hand, and then how to verify it with like another method. That's not on your packet. This one is on your packet. So I think that this one's the easier of the two because it's matching. And you can do process of elimination. So like, for example, number 1, which ones can I eliminate based on just the symbol of it? And why can I eliminate A? Because it's a closed circle. So for number 1, really I'm choosing between B, C, D, and that's it. The rest of them are closed circles. So I think that one would be a smart one. And then you just have to show some work. But here's how you know which one of those 3 it is. When you are solving an inequality or solving an equation too, your goal is to get what alone? The variable. So in this case, it's x. Anytime you're isolating a variable, always start with what is further from it. Would that be the 5 or the 10? And how do I make the 10 0? Subtracting it would make it 0. Whatever you do on one side of the symbol. And when I say symbol, I mean either an equal sign or an inequality symbol. That's what I mean. So then on the left side, 10 minus 10 is 0. I just have 5x. Do I need to flip the sign when I subtract?
No.
No, when do I flip the sign?
Or do anything with negative.
Not anything negative. So when you multiply, and I'll just abbreviate it, or divide by a negative number on both sides, not just one side, on both sides, then you flip the symbol. Otherwise, leave it alone. Keep copying it over like you would an equal sign. So then you don't flip the sign when you subtract. What's 10 minus 10?
0.
And yeah, normally when things cancel, we cross it out, but if it's nothing else on that side, put a 0. Now, x is not alone yet. Opposite of multiplying by 5 is, do I need to flip the sign when I divide by 5?
Yeah. No.
Why not?
Because it's not a negative.
Because it's not a negative number. So you leave it alone. It's x less than what's 0 divided by 5?
0.
0. So then which one must it be? B, C, or D?
B.
D. Yeah, that's the only one that's even on the 0. The others are on different numbers, and then the others have closed circles, which this sign would have to be open because it doesn't have the line. Now, let's say on your final, because this may happen, you have 2 answers that are really similar, like maybe you have this one and also on the 0, but going another way. How do you know which one it is?
The way that the thing is shaped.
So the opening always faces the bigger number, right? So we're saying x is smaller than 0. Which arrow points to numbers smaller than 0?
The left arrow.
That one. That's why this one's the answer. So if you ever run into that, just try testing some numbers. Is -6 less than 0? Yes. Is 4 less than 0? So that's why you wouldn't want the arrow going that way. Make sense?
Yeah.
Okay, which of these looks difficult that you need more help on of these options? Okay. What about from like this side to that side? Because I would need to isolate the variable to see which one it matches.
5. 3.
Okay, I heard 5 first. So number 5 has a fraction. Do we like dealing with fractions?
No.
How can we make it not a fraction anymore?
Multiply by the denominator.
Multiply by the denominator, because fraction bar means divide. So opposite of that would be multiplying. And whatever you do on one side, do it to the other side. Now, you can do that with any fraction. Multiply by the denominator, it's no longer a fraction. So that cancels. I have 3x minus 5. Do I need to flip the sign?
Yes, because negative.
Yes, because I multiplied a -2 on both sides, so that's why I flipped the sign. Notice? And then on the right side, what's -8 times -2? -16.
Positive.
Positive 16, negative times negative is positive. Now that's a lot simpler, isn't it? Now that it's not a fraction. So then keep going. Would I get rid of, the 5 first or the 3?
Oh, you get rid of the 5.
And how do I get rid of it?
Add it. 5 to both sides.
Good. I get, and I'm gonna keep going down. I'll do the rest of the work here. I get 3x. You can just stay there. 21. But make sure you grab 5. So 3x greater than 21, yes. X is still not alone. Opposite of multiplying by 3 is. And do that on each side. Do I need to flip the sign for that? No. Because 3 is not. So leave it alone, still the same. What's 21 divided by 3? All right, so now that it's isolated, I can match it and look, it doesn't have a line underneath. So really I'm choosing between B and C because D is already taken. So which one is it?
It's C.
And why is it C?
Because it's greater than, it's everything greater than 7.
Sorry, yes, it's C because it's on the 7 versus a -2. We're saying that X is greater than 7, so it should point to all the numbers bigger than 7. Good? Let's look at this one real quick, number 6. Again, do we like working with fractions? How can we make it not a fraction? Earlier, someone said, like, work that out, do the 14 divided by 3, but like, unless that decimal ends, don't do that, because it'll throw off your answer. So, you don't have to do that. How can I make it not a fraction? Michael?
Oh, I was putting on the clock, how people were talking. You can make it not a fraction by, it's like multiplying by the reciprocal, I think.
Not multiplying by the reciprocal. That would make it 1. I
Oh,
want it to be just not a fraction. Multiplying by the denominator makes it no longer a fraction. You can do that, but whatever you do to one side of the symbol, you do to the other. Good. So on the left side, and normally you distribute that, right? But really that just cancels the denominator. Nope, you just have to multiply by the denominator and then no longer.
That makes sense.
Do I need to flip the sign?
no.
No, because it's a +3. And then what's 3 times x? X. Yeah. 3x. All right. Now here's another thing we haven't seen yet today. We've seen it before. We haven't seen it yet today. There's x's on both sides. What do I do next? Good. Doesn't matter what side you move it to. Which one do you want to move? And how do I move it? Add x. That makes it 0. Whatever you do on one side. Now, I highly recommend that you move the smaller one always, because then it's less likely you have to deal with negative numbers, and then it's less likely you forget to flip the sign. So if you do that, I think that's a good strategy. You get 14 less than or equal to, what's 3x plus x? 4x. 4x.
So that's why.
By I have 3 X's and I add one more, I have 4 X. And then X is still not alone, what's opposite of multiplying 4? Whatever you want to say. Now, on the left side, that is 7/2, or what's the equivalent decimal?
3.5.
Or 3.5. That one's acceptable because it ends. I can spot that one. Accurate. And then less than or equal to X because the sign, does not change because we divided a positive. And then which graph does that best match?
Yeah, that's probably graph E.
Well, B has an
Oh, wait,
open
no, that's
circle.
E.
It is E, most definitely.
All right.
So look back at the other options of the closed circles. It's not on a 7. It's not on a 6. This one is the best one. Good. Any others from the packet? Any of them? Yeah. Because remember, you could do all of them and get extra credit, so some of you could really benefit. Yes?
Wait, were we only
Tomorrow.
supposed to do one?
No, okay, that's fine.
Wait, I'm confused. China said that I can do all of them. Oh, or this is like, it's a study guide for our final.
It's a packet and one is a cycle theme.
So we do both.
Oh, you get extra credit on your final exam if you do all the options. So again, on your final exam, for example, stop playing. For example, unit 1, I have 2 choices on my final exam. I could do this where I make a box plot and a histogram and answer this question. Or if I think that's really difficult, I don't remember how to do that, I can choose to do this one. The review I'm giving you to do all of, so we have practice with all of them. Because if on your final you do all of them and you get them right, well, we should just do all of them anyway. Get extra credit. You could get like up to a 200%. That make sense? Okay. So any questions on the packet? Bailey?
The one where it's the wheat and the sugar removed.
Okay, that's a good one. So, owner of a small bit, by the way, this is one of your options for unit 4. If you have to, if you're choosing just one to do, I recommend this one, the choice 2, because it looks just like the test we just took. And if you really understood the test we just took, then that should be a piece of cake. It's literally a duplicate, just different numbers. But if you want to shoot for some extra credit, this one isn't that. So the owner of a small bakery bought 60 kilograms of sugar. Each week, the bakery uses 5 kilograms of sugar. Function gives the remaining amount of sugar in kilograms as a function of the number of weeks since the restaurant owner bought the sugar. So first we would complete the table. So what is the starting amount? 60. They're starting with 60 kilograms of sugar. So at 0 weeks, how much sugar do they have?
60.
So then after 1 week, how much sugar do they have? Remaining. 55, because it says they use how much each week? 5. So then at 4 weeks, how much do they have remaining? So 40, let's see. You could go down week by week, but you could also do 4 times 5, right? 4 times 5 is 20. And then take that value and subtract it from the 60 you started with. So then the 20 is how much was used, and then the 40 is how much is remaining. They want to know how much is remaining, not how much they need, but that's how you figure it out. So then at 8 weeks, how much do they have remaining? Because it's 8 times 5, which is,
40.
and then you take that 40, subtract it from the 60, and that's what's remaining. That's what goes here. That's what they want. Now, the last one is just the W. So they want an expression that will give me the sugar remaining in terms of W. So what are we doing with the weeks? What did we do to figure out the first two?
Multiply by 5.
So I should do 5 times W. Yes. How do I show that we subtract that from the 60?
What if we?
60 minus 5W. Isn't that what we did?
Yeah.
But now it's in one expression. And we would multiply first anyway, right? So I don't need to put parentheses around here. Then you could. But we would multiply that first and subtract it from the 60. Good? That's what you would do on your final. That's what it wants. The next part says use function notation to write a rule that defines this function. What does function notation have to have? Normally f of x. This time the input is w. So maybe use f of w. And then what rule defines this function? 60 minus 5w. Because then I should be able to plug in any number of weeks and get an output. Isn't that what we did? Yeah. So that's the function notation of it. All right, and then scrolling down, I'll post this in Schoology too, but like, you still need to copy it down. It says to graph the function. The line already stayed there from earlier, but you have a table of values. I would say use that. Plus you have your starting amount, which will be your y-intercept, right? This really is slope-intercept form. This would be my y-intercept, since it's the number that's alone, and it's my starting amount. And this would be my slope. So I could start at the 60, go down 5 to the right one, down 5 to the right one, or you can just use your table of values. So like at 4 weeks, what was the output? Of remaining? 4. And then at 8 weeks, what was the output? 20, and then you can make a straight line out of those 3 dots. Then it says find the x-intercept. So either keep the pattern going until you figure out what it is, or graph it in decimals, or make your line really straight that you can tell what it is. What is the x-intercept? And what does it mean in this situation?
Well, left.
No, because label the axes. The x-axis would be
12 weeks. A week.
would be number of weeks. So at 12 weeks, and then this would be the sugar remaining. So at 12 weeks, you guys are packing up really early. There is no sugar, 0 kilograms. That's what that means. So no, like time is usually on the bottom. I keep telling you that over and over. What depends on it is on the y-axis. So the sugar remaining depends on how many weeks have passed. Good? Yeah. Okay, don't lose your packet. I'll check it at the end of class tomorrow. But you also have that puzzle piece review to do too, so just keep that in mind. I mean, it auto scored, so technically you could turn it in like at night or something, but like you need to go. Yes.